So on the final page of this test, you're presented with three systems of equations, and you are asked to solve one of those systems using the equal values method. You're asked to solve one using substitution, and you're asked to solve one using elimination method. And you can honestly, do whatever one you want. I'm prepared to look at all of those. Thank you, um, Greg from period, gosh, what is it, period 5? He did all of these. He did this 9 times. He did every system with every method. It was great to see. Good job. I think that probably the one that's set up best for the equal values method is system C. And the reason why I say that is if we take a look at it, notice that C has these statements that x is equal and x is equal. So let's go ahead and solve system C using the equal values method. I'll zoom in here and I'll just go ahead and write it down. I think it's a good idea, even though it's written up above, to just really always write what you're starting with. So I've got x is negative 7y plus 11, and x is also equal to 3y minus 9. My thinking is that if we're trying to find when these points meet, right, these two lines meet on the Cartesian coordinate plane, it would have to be the case that their x values would be the same if they're meeting. So I can certainly say x is x. And then I'm just basically taking the first expression for x that involves y, and I'm writing minus 7y plus 11, and that equals 3y minus 9. If I add 7y to both sides, I get 11 equals 10y minus 9. And then I could, that's right. And then I could add 9 to both sides. So that would give me 9, it would give me 20. So that would give me 20 is 10y. And then if I divide both sides by 10, that would give me that y is 2. So I know that y is 2, I think. Anyways, I'm going to plug that into the second equation because I prefer how it looks. So that's going to just give me 3 times 2 minus 9, which is 6, minus the number 9, which is negative 3. So I believe that x is negative 3. So I'm going to write my answer as an coordinate pair xy because that's what the instructions say. So I'm going to write x is negative 3 and y is 2, and I will close the parentheses there. Now, it's probably a good idea to just quickly check and make sure this works. So if I take my y is positive 2, negative 7 times 2 is negative 14, and negative 14 plus 11 is indeed negative 3. So it definitely works in the first equation. And in the second equation, this would give me negative 3 times negative 3. I'm sorry, y is, I gotta use y is 2. So 3 times 2 is 6, and 6 minus 9 is negative 3. So it also works there. And that's really difficult for me to visualize. I should have written that down, I guess. But yes, that is definitely the solution, negative 3, 2. Okay, so let's go on to one for substitution. Actually, probably I would pick B for substitution just because this is an expression that x is equivalent to. So I'm going to substitute that value of x into the equation above it. So let's go ahead and write this down. So again, I'm doing equation B, and I'm going to write it again. So this is negative 2x plus 3y equals negative 5. And as I do this, my eyes are going back and forth, and I'm just making sure that I'm copying things down correctly. Negative 6y minus 20. And my strategy here is I'm going to take this expression, right, this expression that's equivalent to x, and I'm going to substitute it into the top equation. So I'm rewriting this top equation, and as I rewrite it, it looks like this. I've got negative 2, but instead of x, I'm using this expression. So I'm going to write negative 6y minus 20, and then plus 3y, right? There's a plus 3y, and then that equals negative 5. So now I've got no values of x at all in this equation, just y's. Apply the distributive property, negative 2 times negative 6 is 12y, and then I've got plus the number 40, and that's going to, don't forget to add the 3y, and that equals negative 5. When I combine the 3y and the 12y, that's 15y plus 40 equals negative 5. Take away 40 from both sides, that gives me that 15y is negative 45. And if I divide both sides by 15, I believe that I get y is negative 3. And now that I know y is negative 3, I'm just going to use that fact in this second equation here that'll tell me what x is. So x should be, it is rather, negative 6 times this value of negative 3 and then minus the number 20. So this looks like positive 18 minus 20, which looks like negative 2. So x is negative 2. So as an ordered pair, we've got the negative 2 and we've got the negative 3. Extra credit if you plug that in and I'm wrong, bring it in and show me what I did incorrectly. But I want to encourage you to plug that in and check it, make it happen in your mind, make sure that this is really correct. And if I'm wrong, I've got I don't know, there's a surprise or extra credit or candy waiting for you. So good luck with that. So the only one we haven't done is A, and A needs to be done with the elimination method. So let me go back up and look at it real quick. A was 4x plus 9y equals 11, and x minus 3y equals 29. So again, I'm going to rewrite that 4x plus 9y equals the number 11, and then below that I'm writing x minus 3y equals 29. Now, I don't think I've modeled this enough in the classroom, but when I'm doing these with elimination, I will rewrite both of these. So I'm going to multiply, I'm going to multiply the bottom equation through by the number 3. And when I do that, the top equation stays the same, but it's really useful to write it. So I'm sure what I'm combining it with, those are the equal things that I'm going to combine with other equal things. So let's go ahead and push this factor of 3 across this equation. This is going to pick up a factor of 3, a new factor of 3, a new factor of 3. So this will become 3x minus 9y, and 3 times 29 I believe is 87. 87. Okay, so as we look at, if we have the equal things and we combine these equal things, we're going to get some new equal things, and they're actually going to be, this right hand side combines to 98, and over on the left hand side I get 7x. If I divide both sides by 7, I think that x is the number 14. Yes, it is 14. Okay, so now it's just a matter of figuring out what y is, and either equation could be used. I guess there's no real advantage to either one of them. I'll go ahead and use the top equation. So I'm going to write just 4 times this value of x, 14, plus 9y equals 11. And again, I'm just taking this first equation. I could have picked either one, but I'm taking this first equation, plugging in the x and solving for y. 9y is 11 minus 4 times 14. And then let's go ahead and let's do this. I'll use my calculator at the end. I'm feeling lazy. It's late. 4 times 14, and I'm going to divide everything by 9. So let me bring this up here. So I'm going to take the number 11 minus 4 times 14, and that value is going to be divided by 9, and it gives me negative 5. So y is negative 5. So again, same thing. I highly recommend you take both of these values. Be suspicious of I mean, you know I make mistakes. So x is 14, y is negative 5. If those values satisfy the original two equations, then it is the solution. All right, so that's the last question on the study team test. The Chapter 6 test is coming up soon, so if you have any questions as you're reviewing, please stop by and see me in class.